Hello guys, so welcome to our channel, Ron Basic. In this video, we will learn how to solve your rational inequalities. So on our last video, we solved for rational equations. So it means that we are solving for the x or the unknown of your equation. So this time, we will proceed to rational inequalities. We are still solving for the value of x or any unknown variable with your given rational inequality. So a rational equation has a solution. So in this case, for our rational inequalities, we will be solving for set of solution or solution set. So again, for your equation, you have your solutions or solution. In this case, for your rational inequalities, again, we have your solution set or sets of solution. Okay, so let us proceed with your first example, assuming you have a rational inequality just like this. Example, you have 3 over x minus 2 is less than or equal to negative 1. So for us to solve it easily, so I will give you some basic and fundamental steps in solving this rational inequality. So step one is forming your rational inequality just like this one or in this notation. So assuming your numerator is denoted by r of x and your denominator is denoted by q of x, but you can denote your numerator and denominator by any variable you want. So assuming we have your numerator is r of x and your denominator as q of x, then on our case, let's follow this symbol less than or equal to, and let's put your inequality where the other side is 0. Or our first goal is to make your inequality 0 on its other side. So for now, our reference point is 0. Okay? So how can we get on this form? So we have negative 1 on the other side. So guys, before that, on this symbol, we have your less than or equal to. So it will depend on the case of your given rational inequality. So in our case, we have less than and equal to, but in some other problem or rational inequality, you will be using less than or greater than or equal to. But in our case, again, we will be using this one. So we have less than or equal to 0. So copying the symbol less than or equal to 0. So this is negative 1, your original inequality. And on the other side, you have x or 3 over x minus 2. So how can you make negative 1 0? So what number will we add or subtract? So again, in operating on the both sides of your inequality or your equation, most of the time we are using the inverse operation, or we have minus 1 or negative 1, so we will be adding 1, the inverse. Okay? Or in this case, we are using the addition property of inequality. So just like your equality or equation, you have your addition property. So we added plus 1 on the other side. So we will add plus 1 on the other side for balance. Okay? Or in some cases, we are just saying that we are transposing negative 1 on the other side and it will become positive 1. So again, transposition is not a basic operation in solving rational equations and inequalities, but Most of us using it for some benefits. Okay, so negative 1 plus 1 is 0. And copying the given, you have your 3 over x minus 2 plus 1. So we have on this form, but we are not done yet. So after making your inequality 0 on the other side, we will operate and simplify it to make it a single expression on the other side, such as this. So simplifying means that we will make it a single expression. So we will have this one. So the denominator of 3 is x minus 2. Or let us say that we have to put your inequality or expression in here on a single denominator. Okay? Then plus 1 here, this number 1 times the quantity of x minus 2. So where did we get your x minus 2? So if you want to simplify, let's cover your 3 in here. So you have your 1 times the quantity of x minus 2 over x minus 2. So dividing 1 times the quantity of x minus 2 by x minus 2 over, you will come back at 1. Okay? So it is just like adding your whole number to a fraction and then using LCD on this side of your inequality. Okay? So to simplify, you have 3, this one, plus, okay, 1 times the quantity of x minus 2 is x minus 2. So any number multiplied to 1 is equal to that number. And that is your identity property of multiplication. Okay? So continuing, your denominator is x minus 2 is less than or equal to 0. So if you don't get the identity property of multiplication, just multiply 1 times x. So that will give you product of x. 1 times negative 2, you have negative 2. Okay? To simplify, we have x plus combine like terms, 3 minus negative 2, or if you will put it in order, you have 3 minus 2 over your denominator, x minus 2 is less than or equal to 0. Then simplify again, you have your x plus 3 minus 2, so you have 1 divided by your denominator, which is x minus 2 is less than or equal to 0. So now we have simplified your rational inequality, this one, into this form. So now we will be using this inequality. Okay? So let us proceed to step number 2. So we are done with step number 1. So step number 2, guys, is identifying your critical points. Step 2 is identifying your critical points or critical values. So the critical values or your critical points. So how can we get or find your critical values? So just look at your numerator and denominator. So your numerator is x plus 1. Okay? So this is your numerator. Okay? And your denominator is x minus 2. That is your denominator. Okay, then equate your numerator as well as your denominator to 0. So we are using 0 as your reference point, just like this one. So We are solving rational inequalities, but still we are using your equations or equal symbol just to find your critical values or critical points. So equating it to 0, and then let's find the root of your inequality. So x plus 1 by subtraction property of equality, because we have equal symbol here. So we'll get x is equal to negative 1. Okay? Then we have x minus 2 equals 0. So we will get x equals to negative 2. Then put it on the other side of your equal symbol by, again, addition property of equality. So you will have 2. Okay? So your critical values are x equal to negative 1 and x equal to 2. Okay? So, as a part of your step number 2, let us identify whether x equal to negative 1 and x equal to 2 is a part of your solution set or not, by substituting it to your equation, or sorry, inequality. So we have x plus 1 over x minus 2. Let us check. So we have x plus 1 over x minus 2 is less than or equal to, where x is equal to, first let us try negative 1. Let us try negative 1. So x equals to negative 1 is, by substitution we get negative 1 plus 1 over x, which is equal to negative 1 again, minus 2 is less than or equal to 0. Okay, simplifying, negative 1 plus 1 is 0. Then negative 1 minus 2 is negative 3. Okay, simplifying, 0 divided by any number is 0. Okay, so we have that one. Then we can say that 0 is less than or equal to 0 when x is equal to 1. So we can say that the value x equal to negative 1 will be included in your solution set. So x equal to negative 1 is included. Okay? Let's try x equal to x equal to 2. So x equal to positive 2, then we have x plus 1 over x minus 2 is less than or equal to 0. Then when your x is 2, you have plus 1 here. Then x equal to 2, so we have 2 minus 2 is less than or equal to 0. Then 2 plus 1 is 3. Then 2 minus 2 is 0. It's less than 2 or equal to 0. And here, any number divided by 0 is undefined. Okay? So in this case, because it's undefined, so your inequality will become undefined when your x is equal to 2. So therefore, x equal to 2 will not be included. So again, why x equal to 2 is not included in our solution set? Because x equal to 2 will make your inequality undefined. Okay? So we have identified your critical points. So for your, to understand it more, we will use a line graph to visualize your, what do you call this, your critical values. So example, on your number line, of course, 0 is on the center. Then we have 1, 2, 3. negative 1 on the other side, negative 2, negative 3. The arrowheads of your line graph says that it will continue on negative infinity and positive infinity. So we will just visualize where negative 1 is and positive 2 is. Okay? Okay. So if you can see, these critical values will slice up your line graph. On how many parts? In our case, we have 1, 2, and 3. Okay? So let's go to our next step. Okay, next step, step number 3. So step number 3 is the table of signs. Table of signs. Okay? In your table of signs, we have parts of your table. So we have your interval, so how many intervals? So we have 3 intervals. So let's put 3 columns. Okay. So the intervals of your rational inequality can be seen on your your line graph. Okay? So the values on this line graph are possible values of x. So we can put x in here, and x in here. Okay? So just focus these circles. These circles denotes the values of your, again, critical points or critical values. So your critical values again are negative 1 and positive 2. So this interval separated your line graph into 1, 2, and 3 intervals. Okay? So let's focus on this first interval. So these are the possible values of x or possible values of your solution sets. Because we have 3 sets in here. So let us try to prove whether the sets or values are the solution sets of the rational inequalities. So just remember that when we are comparing values on your number line, the value on the right will always be greater than the values on the left, such as, which is greater, 0 or positive 1? Of course, positive 1, and positive 1 can be found on the right of your 0, and 0 can be found on the left of your positive 1. Okay, so the values on the right are the greater values. So let's proceed. So here is your possible values of x, and this is your negative 1. Which is greater, negative 1 or x? Okay, comparing x and negative 1, negative 1 is greater than x. Again, negative 1 is greater than x. Or by reading it on basic fundamental concept, this is x is less than negative 1. Or you can have it, negative 1 is greater than x. Again, negative 1 is greater than x, or x is less than 1. Okay? So that will be your first interval. X is less than negative 1. Then your next interval is between the two critical values. So the two critical values is negative 1 and positive 2, and x is in between on them. So which is greater, negative 1 or x? negative 1 or x. So x is on the right side of your negative 1. So therefore, x is greater. Okay? Then, between x and 2, which is greater? Of course, positive 2 is greater because we can see that 2 is on the right side of your x. Okay? So the opening of your inequality symbol will open on positive 2. And not to forget, x equal to negative 1 is included. So in your books or on your modules, you can say that you can see there that negative 1 has a solid circle or dot, while positive 2 is a hollow or open circle because it is not included in your solution set. Okay, let's proceed to the third interval. So before that, let us put it in here. So x, then we have positive 2 and negative 1. So the symbol is this one. And we will be putting equal on there. So we can read it as from the center or from x. So x is greater than or equal to negative 1. So greater than because the opening of your inequality is on x. Again, x is greater than or equal to negative 1, but x is less than 2. Less than 2 because the inequality symbol points at x and opens on 2. Okay? Again, x is greater than or equal to negative 1, but x is less than 2. Okay, let us now proceed to your third interval. So third interval is from here to positive infinity. Okay? So comparing 2 and x, there is your number 2 and x. So which is greater, 2 or x? So again, the number or the value on the right side will always be greater. So between 2 and x is on the right side. So the opening of your inequality symbol will open on your x. Or by putting it correctly, will be written as x is greater than 2. Okay? So if you can see, I've written x first than 2. But the opening of your equality symbol is on x. Okay? So they are the same. So we have x is greater than 2. So now we have put all the intervals of your rational inequality. Okay, now let's go to the test points or the test values. Test points. So let us test whether the values here are part of the solution. The values from the left or to the left of negative 1, between negative 1 and 2, and then to the right of positive 2. Okay. So these intervals written in notations dictates the direction of your possible solution set. So this interval is from negative 1 to negative infinity or to the left of negative 1. This interval state the interval or the values between negative 1 and positive 2. Okay? Then, the last interval is the values to the right of positive 2 until positive infinity. Okay? Okay, let us try this one. So what are the test points of these intervals? So what are the values that are less than negative 1? So looking at your line graph, what are the values that are less than negative 1? So less than the values on the left. So we can use negative 2, negative 3, negative 4, negative 5, and so on. But for us to verify it easily, we will be using the most lesser value, or you can say the number closest to your critical value, which is -1. So we will be using -2. Okay? Next, the values between -1 and 2. So if you have to choose, you have 1/2, 1 and 1/2. Sorry, -1/2, 1/2, 1 and 1/2. But of course, let's try 0 and 1. So between 0 and 1, the most basic, of course, is let's try 0. Okay? Then, what are the numbers on the right side of your number 2? So you can use 3, you can use 4, 5, and so on. But again, we will use number 3, the closest and the smallest value possible. Okay? Now let us continue. Okay, so below your interval and test points, you have 3 columns. So the 3 columns are for your numerator. So what is your numerator? Again, do not forget that we will be solving on this inequality and not on this one. So your numerator is x plus 1. Okay? Then your denominator is x minus 2. Then, the last column is for both the numerator and the denominator. So I guess we are clear on this table. Okay? Let us continue. So, this table is called as table of signs. So this table is concerned with the signs of the following values and not the exact value, such as substitute -2 to x. So we will solve it in here. So -2 plus 1, so -2 plus 1 is -1. So the correct answer in here is -1. Again, what is the value of x plus 1 when x is -2? Substitute, so you have -1. Then, let's proceed to 0. 0 plus 1 here. So we have +1. 0 plus 1 is +1. Then, let's write 3 plus 1. So x is 3 plus 1, so we have +4. Again, this table is known as the table of signs, and it only concerns on the sign of the value and not the exact value. Okay? Are we clear? So we have negative, then we have positive, and the last is positive. Let us proceed to x minus 2, where x is equal to. So solving and here, when x is -2, so we have x minus 2, and x is minus 2 or -2 minus 2. -2 minus 2 is -4. So -4, but again, we are only concerned with the sign and not on the exact value. Then 0 minus 2. 0 minus 2, x is 0. So 0 minus 2, we have -2 or -2. Okay, so minus. Again, we are not concerned with the exact value, but the sign of the value. Then we have 3 minus 2. So we have 3 minus 2. 3 minus 2. So we have +1. Okay? Okay, let us continue. So you have x plus 1 over x minus 2. So let us not forget that the fraction bar denotes the operation of division. So x plus 1 divided by x minus 2. So we are just dividing the signs of the following. So numerator divided by denominator is this one. So denominator, negative divided by negative is positive. Then positive divided by negative is negative. Positive divided by positive is positive. Okay, so what's the point of this value? So let's go back to your inequality symbol in here on our simplified inequality. So if you can see, the symbol is less than or equal to 0. So give me the values or the numbers that are less than or equal to 0. So what numbers are less than or equal to 0? Of course, the negative numbers. The negative numbers are less than or equal to 0. All negative numbers. So we will be using this one, the negative numbers. But it is not the answer. This negative sign or negative result in here from a reference point which is less than 0 or equal to 0, it means that we will be using this interval. The interval of x is less than 2 but greater than or equal to negative 1. Okay? Okay. So we have step number 4. So I will erase this part. So on step number 4, we will be writing your solution set based on this interval. So we have three ways to write your solution set. First, solution set. This is your step number 4. Step number 3, step number 2, step number 1. Okay, so step number 4, we have three ways. So first is using your line graph. So it's up to you what comes on your mind first. For me, I will use first the line graph to visualize your solution set. So a line graph looks like this one, just like the line graph we have made earlier, but more precise. Okay. So the solutions. So we have 0 at the center, we have 1, 2, 3, and so on. Then we have negative 1, negative 2, and negative 3. You can extend your line graph on what value you want to be. Okay. So again, your critical points are negative 1. So again, negative 1 is included based on the line graph that we have drawn here. Then you have your positive 2. So it's based on your interval because you have this symbol less than or equal. So equal included. Okay? So where can we find this interval? On the left side, the right side, or at the center? Of course, at the center. So in between. So shade this part. If you shade this part, it would imply that the values between positive 2 and negative 1 are the values of your solution set, where positive 2 is not included, while -1 is included. So that is your line graph. Second way of writing your solution is using your interval notation. Interval notation. Okay, so an interval notation can be written this way. Okay, so I will write first the value. So interval notation, we have values of -1 and 2. -1 and 2. -1 and 2. Then we will be using this bracket and parentheses. So we use bracket here because it is included in our solution. If it is not included, then we will use this parentheses. Okay? Then the third is using your set builder notation. Okay, so your set builder notation looks like this. So braces, x is an element of your real number such that copy this interval from here. So you have your x is greater than or equal to -1 but less than 2. Then braces. So we have here 3 ways to present or represent your solution set for this rational inequalities. So you have your line graph, your interval notation, and your set builder notation. Again, thank you for watching.